Okay guys, so we'll be continuing on seeing more on types of reversible electrodes. So let's get started. So now we'll be seeing Quinn hydron electrode. So this is the fourth type of electrode, which is Quinn hydron electrode. Quinn hydron electrode. Okay, so in general, quinone and hydroquinone are mixed in equimolar solution, and gold wire is immersed into the solution. So in general, quinone and hydroquinone are mixed in equimolar solution and then gold wire is immersed into the solution. Okay, so next we'll be seeing the structure of quinone and hydroquinone. So this is the structure of quinone, and this is hydroquinone. Hydroquinone. Okay, so this is Q and this is QH2. So we'll be seeing representation of the same as an anode. So we can see that QH2 gets dissociated into Q aqueous plus 2H aqueous plus 2 electrons. So we can write that on surface of gold, QH2 aqueous is getting dissociated into Q aqueous and H plus aqueous. Okay. Oh, I forgot charge on Q. So this QH2 is QH2 would be getting converted into Q2 minus and 2H plus. Okay, so next E of QH2 Q2 minus and H plus can be written as E naught of QH2 Q2 minus H plus minus 0.0591 upon 2 log of concentration of Q H plus squared divided by concentration of QH2. Okay. Then we have fifth type of reversible electrode. So wherein we will be seeing metal sparingly soluble salt electrode, metal and sparingly soluble salt electrode, so we will have a combination of metal plus its sparingly salt, or rather soluble salt, plus source of anion. So we would be seeing that we have this container, so which actually has layers. So the top layer present is KCl aqueous, next layer present is Hg2Cl2 solid, and the bottom layer present is mercury liquid. Okay, similarly we can have another example wherein we would have top layer as NO2SO4 aqueous, middle layer present is, let's say this is PbSO4 aqueous, and the last layer present is Pb in solid form. Okay, we can have another example in which we have container, top layer present is KBr aqueous, middle layer present is AgBr solid, and bottom layer present is Ag solid. Okay, so we can have an apparatus in which metal wire is coated with its sparingly soluble salt and dipped into solution of electrolyte, which is the source of anion. So we can have metal wire coated, which is porous with its sparingly soluble salt and dipped into solution of electrolyte, which is the source of anion. Okay, so we can have such apparatus in which we have, according to the above statement, we have a metal wire coated with its sparingly soluble salt. So this is the surface of, let's say, silver, and this surface is coated with a layer of its sparingly soluble salt. So let's say we have the coating of AgClS, and the whole apparatus is actually dipped in solution of electrolyte, or electrolyte which can provide anion, or which is the source of anion. So we can have KCl aqueous as the source of anion. Okay, so this is whole apparatus set up in this type of electrode. Next we have Kelvin electrode. So in Kelvin electrode, what we have is this setup. We have a beaker type setup. So this is the apparatus in which again we have a solution of HCl aqueous. So this is first the solution of HCl aqueous. Next we have paste of Hg2Cl2 solid form, and at the bottom layer we have liquid mercury. Okay, and we are immersing platinum wire into the apparatus. So this is the platinum wire. So we can write that the following reaction would occur between the states or between the different layers, that Hg2Cl2 in the paste form actually ionizes into Hg2 plus 2 aqueous and 2Cl minus aqueous. So if this electrode is worked as anode, so if this electrode is worked as anode, then we can write that 2HgL would actually form Hg2 plus 2 aqueous with the deletion of 2 electrons, and the form Hg2 plus in plus 2 state would actually combine with Cl minus to form Hg2 Cl2s. Okay, so this whole reaction would occur if this electrode is worked as anode. Okay, so net half cell reaction can be written as just combining these two equations. So we would be getting 2HgL plus 2Cl minus aqueous forms Hg2Cl2 S plus 2 electrons. Okay, so talking about the half cell representation, we can have PTS on which the reaction is taking place, then we have HgL, and then we have Hg2Cl2 in solid phase and Cl minus aqueous in aqueous phase. Okay, so we can write E of Hg to Hg2Cl2 and Cl minus as the ion source or anion source. So this is oxidation potential of caramel electrode. And this would be E naught Hg, HgCl2 and Cl minus as the electrolyte or anion source, which would be equals to SOP or standard oxidation potential of caramel electrode. Okay, next we see that what actually happens when the same electrode is worked as cathode. worked as cathode. So I will request you to work upon this and derive how this electrode would work as cathode, and we will discuss on the same in the next lecture. So till then, good luck and goodbye.